Hello everyone and welcome back to today's screencast. It's on probability, it's on tree diagrams, but we're going to look at how to use the information that we learned from drawing. So make sure you've done the screencast on drawing the tree diagrams first. Okie dokie. What is a probability tree? Very simply, we did this yesterday, but hopefully when I read this it'll make more sense to you. Tree diagrams are a way of showing combinations of two or more events. Each branch is labelled at the end with its outcome and the probability is written alongside the line. It comes from BBC Bitesize. We're using the information today. So although we will go through the process of drawing, we're actually looking at using in more detail. So we're going to go through this one here, the first flip and the second flip, and using the coin. So we've got our coin, we've got our first flip, we're going heads or tails. Hopefully this all looks familiar to you. Remembering the probability of me flipping a head would be 1/2, or flipping a tail would also be 1/2, and that's because there's only two sides to a coin. We've got one head, two sides, one tail, two sides. But now we're remembering we're going to flip a second coin, aren't we? So don't worry, this is all exactly the same as the last screencast we've done, but we will make a big difference very, very shortly. So here we go, second flip. Remember we could get a head or a tail and the probabilities are going to stay the same, 1/2 and 1/2. But if we flipped a tail for the first time, then we'd have some different ones, wouldn't we? We'd have heads and tails again at 1/2 and 1/2. Now we're going to write all the outcomes because we could have flipped a head and a head. So that would be head, head. And that would be 1/2 timesing by 1/2, which gives us 1/4. So a quarter of the time we're going to flip head, head. But we've also got the outcome of head, tail, and we've got to do that one as well, head and tail. And it's still 1/2 timesing by 1/2 gives us 1/4. Exactly the same as yesterday. So this all should make nice, easy sense to you. But we could have flipped a tail on the first one and a head on the second one. So we'd get 1/2 timesing by 1/2, which gives us 1/4. Okay, we're getting near to the question. Don't worry, getting near to the question. But we could have done a tail and a tail. So here we go. Tail and tail, which is 1/2 timesing by 1/2. Guess what it equals? That's right, everyone. It equals 1/4. But here is where we throw in the curveball and we use this information to answer a question. The question is this: what is the probability that you will flip the same side twice? Let's look at this in more detail. First of all, we've got to assess when we flip the same side twice. A head and a tail, that's not the same side twice. A tail and a head, that's not the same side twice. But we have got a head and a head here, and we've got a tail and a tail there. Now, believe it or not, to write down the probability of flipping the same side twice, all we do is we take this 1/4 here and this 1/4 here, and we add them together. So I've got 1/4 plus 1/4, and that gives me 2/4. And 2/4 is also a half. And that is how easy it is. Because let's have a look. Half the time, I would either flip a head, head, or a tail, tail, won't I? That's half the time. The other half, I'll flip non-matching sides. So we have 1/2 as our answer. Hopefully that makes sense to you. Hopefully that makes sense. Let's look at another question now. Let's bring up the old counters bag and let's go through the process. So hopefully you remember this one where I'm going to pick out a counter once, put it back, and then pick another counter out. I've got 6 reds in my bag, hence the 6. I've got 10 counters in total, hence the 10. The blues, I've got 4 out of 10 will be blue, and then I'm going to go for a second pick, and it's going to still be 6/10 because I put the counter back, and it's still going to be 4/10 because I put the counter back, obviously. And then remember, if I didn't I didn't pick a red out on my first occasion, then I'd pick out a blue. So then I've got to do those options as well, and I'm going to go through that process. Remember, all the possible outcomes would have been red red, red blue, blue red, or blue blue. And to work out the probability of getting these, we would multiply them together, which we did yesterday, and I'm sure you all did really well, hence why you're watching. But here comes the question. This is the difference between the two screencasts. What is the probability that you'll pick two different coloured counters out? So we need to look at that in more detail. Where do we pick out two different coloured counters? Where? These are the same. These are the same. These are different. So we identify them, and remember how we do it. Pause the video if you think you can do it on your own now. All we do is we add them together. 24 over 100, adding 24 over 100 gives us 48 out of 100, which is slightly less than half, isn't it? Now, I know that that could cancel down, but right now I just want to leave it as that. Very important that we have that understanding, that we are looking at our question, then we're identifying, and then we're adding. And you might notice, like this is where some people go wrong. They go, well, you times, and that's different to adding. Yes, you need to know how to add fractions. You need to know how to times fractions. But if you do, you will be absolutely fine. So our answer is 48 out of 100. Or it can be cancelled down to 12 over 25. So either one of those would be correct. Okay, so now it's up to you. I'm going to go through the process. You're going to answer it. If you can if you can pause the video now and do it all from here, that's fantastic. If you need a little bit of help from me, then you can pause it a little bit later. But at some point, you need to pause this video, work out your answer as we go. So let me just help you out. I've got my five reds and my 4 blues. I'm going to do my tree diagram to represent this data. I'm going to give all the possible outcomes, and then I'm going to work out what the actual probability of getting them all is. Now, we have got the question, which is, please draw a tree diagram, represent this, and work out the probability of picking matching blue counters. Matching blue counters. So we need to look here and we need to say, is that matching blue? No. Is this matching blue? No. Is this matching blue? No. Is this matching blue? Yes. Identify it. Identify it. Is there other matching blue counters? No. So what do I do? Very simply, my answer should have been 16 over 81. There is nothing else to add to it. So my answer is just 16 over 81. Okay, everyone, it is now time for the quiz. Please go through, do this whole question out, and just remember that the question really, the difference between the last screencast and this screencast is, what is the probability of picking out at least one red counter? Give it a go, come back and see if you've got it right. Remember, only do this if you're feeling confident. If you're not feeling confident, seek help. Try watching it again. Go and research lots of other great websites just before you do this. We want you to be successful. Being successful is a massive, massive part of being positive, and being positive is a huge part of being successful. They work hand in hand. Pause the video, give it a go, come back and see if you've got it correct. Okie dokie, here we go. So this is everything that you needed to do. Remember, where I got at least one red counter was here, here, and here, but not here. So I added them all together and I got 21 out of 25. That is our answer. Hopefully you've done really well. Pause this video here and really go through what you've done and what I've done, especially if it's a little bit different, and especially if you've made a slight error. Slight errors are okay as long as we learn from them. As always, very important to write a good revision card on this topic. If you want the electronic versions, get in contact with me via the comment section below, and I'll happily help you out there. As always, it's been a massive privilege helping you with your maths today. Hopefully you've found it successful. Hopefully you feel more positive, If you don't worry. It's a speed bump in the road. Some things are hard, some things are easy. Some people will find this easy, some people will find this hard. But until next time, see you later.